So I thought I'd do a build video for the Softrock RXTX Ensemble kit that's sold at 5-.com. The kit radio is an SDR transceiver that covers in various band configurations all the way from 160 through to 10 meters. And you get everything in the kit that you can build various band combinations in there. Not the complete 160 to 10, but for example, you can build 40, 30, and 20. Now the radio itself is it's not a complete radio. It does require the use of a PC and SDR software of your choice on the PC. You connect the radio to your PC via USB, and because it is an IQ style of radio, you connect your line in and line out from your sound card on your PC to the radio for passing of signals in and out. So the software that I've chosen for this radio is HDSDR. No particular reason. I already had it. I was already using it with some of my other radios, so I already had it installed. I didn't have to do that again. There is some additional software that you have to install on the radio itself, and there's full instructions for that. I won't go through that. This is more of a build video, but there is a link that I'll provide in there in the kit to a site called w5rz.org. Now that has a great selection of build instructions, and it was what I used to build the kit, and very helpful, very instructive. So let's walk through first what you get in the kit. And then after that I'll go through a simplified block diagram of the radio, and then finally I'll walk through the schematic and show the sequence of that I'll be building this in. So just zooming in, I've got the board mounted here on, and you can see that it's a combination of through-hole components and surface mount components. So this is the top of the board here. So here's where all the through-hole components go. On the underneath of the board, use the light there. Let me just move that so you don't get to see the glare. So on the bottom of the board, this is where you mount all the surface mount components. So you can see here the pads for them here, here, and here. For the ICs, there's the pads here for the SI570 synthesizer. So you can see it's a mixture of both surface mount as well as through-hole components. And note that none of these through-hole components are actually installed. So you have to be pretty comfortable in this kit installing SMD components. Obviously there's plenty of practice videos out there that show you how to do that, but yeah, you have to be fairly comfortable with soldering SMD parts to build this kit. Now, fortunately, most of the surface mount components aren't too tiny, and there's a couple of exceptions which I'll go through later. And you can see here, it's a combination of there's some SSOIC 14, SSOIC 8 surface mount components here. They're pretty easy to solder in. There's also, you see here, there's pads for capacitors here and here, for example, here and here. Now, there's two tricky components, and I'll zoom in on those if I can. Let me just move that on here. So there's a 3.3, trying to get some focus here. There's a 3.3 volt regulator, this one here, and then there's the SI570 itself. They're a bit of a pain to solder. The SI570, not so much because the pads are close together, but rather it doesn't actually have any tabs on it. So you have to actually solder it in place here, and it is quite tricky. Now, fortunately, on that the site that I mentioned before, there is a video by W2AEW that has a video that describes how exactly the best way to solder this in. It was very helpful to me, and I'll provide the link to that in this down below the video. So what else do you get in the kit? So also in the kit is all the the toroids that you need. There's some number 26 wire, there's some number 30 enameled wire. So you get all that. Obviously, in a static safe bag, you've got all the ICs. Now this kit is a Talo detector style kit, and it uses the FST 3253 chip that I actually did in another video series. So what else have we got going on here? Obviously, the static sensitive bag also contains the set of BS 170 FETs that are used quite prolifically throughout the kit. Also, you get in the kit, let me just move this over here, you get all the hardware that you need to all the stereo jacks in. So there's 3 by 3.5 stereo jacks. There's a USB-B style jack. There's also a 2.5mm power plug jack and an associated jack, and there's a B and C connector for the antenna. So let's now quickly walk through a very simplified block diagram that I've pulled together for this radio. It describes all the major components at a high level, so you can see what connects to what and what's the responsibility of the radio versus the PC. So as I mentioned before, this side is the PC side. I've got HDSDR running. Now HDSDR allows the selection of an abstraction layer in this, these so-called XDIO DLLs. And you get, obviously, there's one of these per different type of radio you're connecting to. So that's part of the software install that I mentioned, is there's an XDIO DLL that's specific to the Ensemble radio. And so this abstraction layer, HDSDR, talks to XDIO DLL and its own protocol. And then the XDIO DLL transmits instructions to an AT-Tiny that's actually on the Ensemble board itself to, for example, change frequencies. So the AT-Tiny is an 8-pin microcontroller. The microcontroller itself comes pre-installed with the Ensemble software, so you don't have to load any software on there. The AT-Tiny is primarily responsible for controlling this SI570 synthesizer. This synthesizer produces the local oscillator frequency. Unlike the synthesizer that is in the earlier videos that I have, it doesn't have any capability to output a local oscillator in quadrature. So you can't get directly out of this SI570 the local oscillator frequency at 0 and 90 degrees. So it runs 4 times the local oscillator through this D-type flip-flop configuration that actually produces the 0 and 90 degrees that is required by the Talo detector and the encoder. So on the receive path side, the signal comes in through the antenna, is presented at the Talo detector. Now the Talo detector is receiving a 0 and 90 degrees local oscillator signal. So it's a direct conversion receiver that you get the baseband signal in quadrature coming out of the Talo detector. So that quadrature baseband, the audio signal, gets transmitted back to the HDSDR software for processing. So the HDSDR software uses digital signal processing to extract the audio signal from the I and the Q signals that is presented. Conversely, on the transmit side, HDSDR on transmit sends an audio signal, again in quadrature, to the encoder block. The encoder block takes the I and the Q signals, again passes it through a Talo style encoder, and out of that you get the actual mixed signal, RF signal, and and it depends whether, obviously, the band that it's on, whether that's the upper or the lower sideband, and then that gets sent through the antenna. So that's a simple block diagram of the radio itself. So in terms of how we're going to actually attack the various components in the circuit, let me just walk you through kind of my plan of attack, and we can see that after each stage there'll be some way that we can actually test that stage is working. So the first part that we'll attack is the 12-volt power in, 5-volt regulator, and the filtering that we have here. The second part is the AT-Tiny itself, which is here. The 3.3 volt regulator for the SI570. And after this part is all together, we'll actually be able to connect it up to the PC, and we'll be able to test that the AT-Tiny is able to control the frequency output of the SI570. The next part that we'll install will be the 0 and 90 degrees local oscillator output from the D-style flip-flops here and here. Following that, we'll install the low-pass filter, which is just here, and the detector power control circuitry. Following that, we'll do the halo detector itself down here. Then we'll move on to the encoder. And then finally, we'll have the driver and PA circuitry, and after that we'll be complete. So that's the plan of attack. I'll post a series of videos starting with each of these that I've mentioned, and I'll be sort of demonstrating after each section how you can test this to make sure that section is built and working. And that's all for now.